Hi everyone. So in this video, we're going to continue to talk about right triangle trigonometry. Specifically, we're going to do some examples that are a little bit different from the examples in the last video in terms of what kind of information is given to us and what kind of information we're trying to find. And then we'll eventually do a couple of examples of word problems so you can see how right triangle trigonometry is useful in solving real world situations. So before we get into the kind of new stuff, I want to do one example that's more similar to what we did in the last video, just to kind of contrast what's going on in this video versus the last video. So in our last video, most of the examples we did, I think with just one exception, we didn't know what the angle was, right? And we actually didn't really care what the angle was. Really, the goal was just to evaluate trig functions of the angle. So in those examples, we knew the sides of the triangle, and we were just kind of writing down sine of theta, cosine of theta, tangent of theta, etc., using what was known from the triangle without ever figuring out what theta itself was. So let's just do one example like that just to kind of remind ourselves how that works. So I would encourage you to pause and try this yourself. Just evaluate sine, cosine, and tangent. That's enough for this quick warm-up example. So one thing you might notice in this example is that the hypotenuse is missing, but that's okay. We can find it. If you have two sides of a right triangle, regardless of what the angles are, you can always find the third side using the Pythagorean theorem, right? So if we use the Pythagorean theorem to find that third side, we have 2 squared plus 5 squared is equal to c squared. And so that tells us that, so we have 4 plus 25, so that's 29 is equal to c squared. And I'm running out of space, so I'm not going to quite solve that, but that tells us that c is equal to square root of 29, right? So that's our hypotenuse. So that's not really part of the trigonometry part, right? That's just using the Pythagorean theorem. But once we have all three sides, well, then we could just go ahead and use the ratios that we introduced in our last video. So in our last video, we learned that sine of an angle, if that is an angle within a right triangle, is going to be equal to the opposite side over the hypotenuse. So in this case, that's going to be 2 over the square root of 29. We can rationalize that by multiplying by square root of 29 over square root of 29, and we would get 2 root 29 over 29. And then cosine of theta, well, that would be equal to the adjacent side. So remember, cosine is adjacent over hypotenuse, so that's going to be 5 over the square root of 29. And so again, if we rationalize that, that's going to be 5 root 29 over 29. And then tangent is opposite over adjacent. So tangent of theta is the opposite side, so that would be 2, right? That's opposite of the angle, over the adjacent side, which is 5. So we get 2 over 5. And then, you know, in our last video, we would usually find the other three ratios, which could just be found by taking the reciprocals of each of those. So again, this is like we were doing last video. We don't know the angle. We do know the sides, or we can at least find them using the Pythagorean theorem if there's any that are unknown. And then from there, we just write down what these different ratios are. Okay, so in this video, we're going to be focusing on questions that are set up a little bit differently. So we're going to be doing problems where the angle is known. And we're going to then use use trig functions, basically use sine or cosine or tangent. We'll see, it kind of depends on what information is given exactly. We're going to be able to use those to actually find the sides of the triangle. Okay, so for example, in this problem, we're given that our triangle has one angle of 35 degrees and one side of length 12. And we're asked to find the remaining sides and angles. So before we start with that, I want to kind of label this triangle because I think it will help us to be able to refer to things more easily. So let's call this angle here A, and that means that this side here is going to have a lowercase a. So I introduced this way of labeling in one of our, I think maybe our very first video, where if you label one of your angles or your vertices with a capital letter, then there's kind of a convention of putting just the lowercase, oops, not C, B, the lowercase of that letter across from it. So little a is across from big A, little b is across from big B, and then we can call this angle C, and so little c would be 12. Okay, so how are we going to find our remaining sides and angles? Well, we can find this remaining angle just by using the fact that the three angles have to add up to 180, right? So if we know that we have 35 plus 90, and then we're trying to see what angle goes here, we can just do 180 minus 90 minus 35. And so that will give you, if you do that out, that will give you 55 degrees. Okay, so how are we going to find the missing sides now? Well, let's try to write something down that we know in terms of trig functions. So for example, one thing that I can write down based on the information we have here is that sine of 35 degrees, according to our picture, that should be equal to a over 12, right? A is the opposite side, and then 12 is the hypotenuse. And so we're trying to find side length A, right? That's one of our unknown sides. And so I'm just going to multiply both sides by 12 and kind of rearrange the equation. So it's written now as A is equal to 12 times sine of 35. Okay, so how does this help us? Well, sine of 35, that's a number, right? Like sine of 35 is some number, and it's not one of the nice ones that we know, right? For example, if this was 30 degrees, we could figure out what sine of 30 degrees was by using special right triangles or by going on the unit circle, or if it was 45 degrees or 60 degrees. 35 degrees is not one of those angles. However, this can be found using a calculator, right? We can type sine of 35 degrees into a calculator. And make sure, earlier in the quarter when we were using a calculator, I asked you to make sure your calculator was in radians mode. Now you might need to switch it back to degrees mode. And from here on out, we might be kind of going back and forth. So just be cognizant of whatever, units we're using in the problem. Make sure that your calculator is set to use those units, or else you'll just get completely the wrong answer. So if you type all of this into your calculator, what you'll find is that 12 times sine of 35 degrees is about equal to 6.88. So that's going to be the length of our side A here. So I'm just going to fill that out. A is approximately equal to 6.88. Now we know that. And by the way, so if you're using a calculator for this, which you kind of have to, I would highly recommend that you do it all at the end. And what I mean by that is it's tempting, I think, to at this stage type sine of 35 into a calculator and kind of get some decimal approximation and then multiply that by 12. And what can happen with that is like the earlier in the process you round. So if you're doing a math problem, not even just with trig, with any kind of math problem, if you're doing a math problem that requires that you use a calculator, the earlier in the process you use the calculator and kind of end up rounding things off, the more potential there is for your answer to get further and further off as you do more calculations. So as a general rule, you want to wait to type things into your calculator until like the last possible moment. And so in this case, that would mean first solving for A, and then you can type 12 times sine of 35 into your calculator all in one go. Okay, so how do we now find the side with that we've labeled with B? There's actually a few ways we could proceed from here. One thing you could do is you could actually use the Pythagorean theorem, although that might make your answer a little bit further off because A has already been rounded, right? We rounded A when we wrote it down. So let's actually try to use trigonometry to find side length B. So we have a few choices here. We know that we have an angle of 35. We know that we have an angle of 55. Let's say we want to keep using the angle of 35. Well, what trig function would we want to use if we're trying to find B? Well, you want to use cosine, right? Because cosine is what's going to relate the adjacent side and the information that's already known. So we'd get cosine of 35 is equal to b over 12. And then similarly to what happened in the last one, we can solve this for b. And so we get b is equal to 12 times now cosine of 35 degrees. And once again, you want to type that into a calculator. So if you type 12 times cosine of 35 degrees into your calculator, you should find that it is approximately 9.82. And one thing that's kind of nice to do on these problems is remember that rule about how the biggest side should be across from the biggest angle. That's kind of a nice way to just double check that you didn't make any careless errors. So in this case, notice that our biggest angle is the 90-degree angle, right? And so that's across from the hypotenuse, which is the biggest side. But then if we look at what is our smallest angle, 35 degrees, that's across from 6.88, which is the smallest side. And then 55 degrees, that's a little bigger. And so the side across from it's a little bigger. So that can help make sure that you don't like mix up your two sides or something like that. One other thing I want to mention is that this is not the only way to find side length B. We could have done a few other things. We could have actually used this angle instead. We could have said sine of 55 is equal to b over 12, right? If we said sine of 55, then we would be talking about the opposite side. So sine of 55 is b over 12, and then solve it, and you would get the exact same answer. I would actually encourage you to do that. Try that yourself. Try doing sine of 55 is equal to b over 12 and convince yourself that you get the same answer. There's even more we could do. We could actually use tangent. We could say tangent of 35 is equal to 6.88 over b. And then solve that for b. Again, that would be a little further off because 6.88 is already rounded. So it's generally better to use the side lengths that you know exactly. So for example, 12 we have exactly, right? That was given to us. But my point is that there's always a lot of different ways to do this. It kind of just depends on which angle you're choosing to focus on and which side you're trying to find. As long as you're writing down some kind of a true statement using trig functions, you should be able to get to the answer. Okay, so this is the same kind of idea that we're going to be using now in a couple of word problems. Before we get to the actual word problems, there's just a little bit of vocabulary I want to introduce. So not every word problem with trig uses these, but some word problems refer to something called the angle of elevation and the angle of depression. And so the angle of elevation, that would be used in a situation where you have an object that is above another object. And so, one example that you could imagine is, say you're standing, on the ground and you're looking up at a plane in the sky. If you were to measure the angle that kind of goes from your position vertically up to where the plane is in your line of sight, that is called the angle of elevation. So it's kind of like imagine, where are your eyes looking as they're looking up at the plane? How angled do you have to look up to look at that plane? And then similarly, if there's something referring to an angle of depression, so that's used when one object is above another one and it's kind of looking down on it. So for example, now let's say that we have a plane that is flying above the ocean and someone is kind of looking down from the plane to a boat. So if you take the angle that is compared to horizontal, so compared to if you were to go kind of straight across, how far do you have to go to get to kind of looking at that boat, that would be the angle of depression. I know it looks like it should be a negative angle, but we would still actually measure it positively. And really it's because we're doing right triangle trigonometry here, right? So if we were graphing an angle on the unit circle and we were kind of going this way, we would consider that negative. But in this context, basically just think of it as being like an angle in a triangle. So we'll count it as being a positive angle. Okay, so I want to do a couple of examples making use of this. So this first question says, you are standing 1 mile from the Empire State Building. So Empire State Building, if you're not aware, is a really tall building in New York City. And it says the angle of elevation to the top of the building is 15 degrees. Find the height of the building. So let's start by drawing a picture. And that's really what you want to do in all of these. And I know a lot of people seem to be very hesitant to draw pictures. It doesn't need to be perfect, but I just think it's really, really hard to make sense of these problems without at least drawing something. So let's say that you're standing here. Maybe let's make ourselves pink. So here's us. And then the Empire State Building is all the way over here. So Empire State Building, I don't know, I think it kind of looks like this. It has like a tall, I've been there before. I don't quite remember what it looks like. Something like this. Okay, so let's say this is the Empire State Building. And so the angle of elevation being 15 degrees, what that means is that this angle here is 15 degrees. That is our angle of elevation. Okay, so what other information is given and what information are we trying to find? Well, we're told that we are 1 mile away from the building. And so that means that this distance down here is 1 mile. And then what are we trying to find? We're trying to find the height of the building. And so that would correspond to this distance here, right? So maybe let's just call that x. So looking at this picture, we can see that we have a right triangle, right? And so basically all of these kinds of word problems we're going to be working with are going to be word problems that kind of turn into just a right triangle. So you can take this real world situation and turn it into a right triangle, and now we can go ahead and use right triangle trigonometry. Okay, so there's, like I said in the last example, there's always a lot of different ways to approach this. Generally speaking, you want to think about what is the simplest way. So what would be, in this case, a function, a trigonometric function that would make use of the information that is given to us as well as the information that we're trying to find out. So in this case, we're given the adjacent side, right? If we compare the angle we know, 15 degrees, that is adjacent to 1 mile. And then the side we're trying to find, well, that's the opposite side. And so what would be the trig function that kind of relates the adjacent and the opposite side? Well, that would be tangent. So the thing we want to write down is that tangent of 15 degrees is equal to opposite over adjacent. So that is x over 1. And so in this case, it kind of works out nicely. It's just 1, right? It's we don't have a denominator that we have to multiply both sides by. We can just kind of jump straight ahead and say, oh, okay, that just means that x is equal to tangent of 15 degrees. And so now you want to type this into your calculator. So type tangent of 15 degrees into your calculator. I'm going to keep a few more decimal places than I did on the last one. So if you type this into a calculator, you should find it's about 0.2679. And what were our units again? They were miles. So that's kind of a weird unit, right? Like that's not exactly how I like to, if someone tells me a building is 0.2679 miles, I feel like that doesn't really mean much to me. So what we can do is convert it to feet. That will kind of help us to really be able to make sense of that measurement. So this is something I actually talked about at the beginning of the quarter. How do you go about converting something from one unit to another? Well, you can multiply it by kind of this conversion factor. So by this fraction that will get rid of your old units and introduce new units. So if we take 0.2679 miles and we multiply it by however many feet there are in 1 mile, that will leave us with the building measured in feet. So the number of feet in a mile happens to be 5,280. So if you do this multiplication, the miles are going to cancel out, and we're going to be left with our answer of the height being about 1,000, I should say equals about 1,415 feet. All right, so one more example. This one is now going to involve an angle of depression. So in this problem, we have a 200-foot tall lighthouse, and the angle of depression looking down from the top of the lighthouse to a boat in the distance is 23 degrees. And we want to find the distance from the base of the lighthouse to the boat. So I'm going to start by drawing a picture. I'm going to try to draw a lighthouse my best. We'll see how it comes out. So something like this. Believe it or not, I've practiced this and I still can't do it. Okay, so lighthouses, sometimes they have some stripes. Maybe I'll throw some stripes on there. Okay, so that's our lighthouse. And, maybe it's on a little bit of land here, but then we have some water. And we have a boat somewhere out there in the water. What's a good boat color? Maybe I'll use this brown. Oh, that's thicker than I expected. Okay, so I've got a boat out here in the distance. And so the angle of depression is supposed to be 23 degrees. So what does that mean? How do we interpret that? That basically means if you were to go straight across horizontally and then measure downward, so measure like from the horizontal, draw a line straight down to the object that we're looking at. And then this angle here, that is our angle of depression. And so that is going to be our 23-degree angle. Okay, so what other information are we given that would be helpful here? Well, we know that the lighthouse is supposed to be 200 feet tall, right? And what are we trying to find in this problem? Well, we're trying to figure out the horizontal distance from the lighthouse to the boat. So one thing I want to point out is that, there's a few different places we could label that horizontal distance. The first thing you might think of is putting it down here, is saying, okay, this is the distance X we want to find, right? But if we look at the triangle that is basically kind of jumping out in this problem, it kind of makes more sense to actually label it up here, right? It's the same distance. It's kind of like forming this big rectangle. But in order to make use of this 23-degree angle, we really want to be able to use this right triangle up here. And so let's label that kind of side across as X. And by the way, you could actually use this triangle down here. So see how we kind of have two right triangles that are sort of nested together to create a rectangle. But if you wanted to use this triangle down here, you would have to then subtract 23 from 90 to figure out what this angle is. Not like that's a whole bunch more work or anything, but it just feels a little more natural to just use what's already given to us. And then there's one more thing we have to do, which is that we know that the lighthouse is 200 feet, but we want to actually translate that into our triangle. And so that means that this distance is also 200 feet, right? Because it's the same height. We're just kind of doing it on the opposite side of the rectangle. Okay, so now we have our triangle, and we know that we're trying to find this distance X. We know this distance 200. So what would be a trig function that could relate X and 200? Well, once again, tangent is kind of the most natural of the angles to use. So we can say tangent of 23 degrees is equal to the opposite side, so that's 200 divided by X. So the setup on this is a little bit different because we want to isolate X, but it's going to take like 2 steps to get there rather than just doing one multiplication, right? So if we start by multiplying both sides by X, we're going to get X times tangent of 23 degrees is equal to 200. And then we have to divide both sides by tangent of 23 to isolate X. So we get X is equal to 200 over tangent of 23 degrees. And again, I really encourage you, don't type tangent. I think it's very tempting to like right away be like, I just want to see this as a number. Tangent of 23 is a number. You can just leave it written as tangent of 23, and it works just like any other number. You can multiply both sides by it, you can divide both sides by it, you can do whatever you want, just like you can do with any number. But by waiting until the last moment to type it into your calculator, you're not going to have your answer get off as much as it might by rounding earlier in the process. So if you type this into a calculator, 200 divided by tangent of 23, you should find that that is about 471.17 feet. So hopefully you can see how trigonometry can actually be used in the real world, and people actually use this. Surveyors have traditionally used methods like this to figure out, distances. If you can measure an angle, then if you know how far you are from something, you can measure its height. Or if you know how tall something is, you can figure out how far you are from it. So right triangle trigonometry is really powerful in that it lets us kind of take information about angles and turn it into information about distances. So that's it for this video. Please take a look at the worksheet because there's a couple more examples of different kinds of word problems that you can do using right triangle trig. And yeah, I'll see you all in the next video.